Hello everyone. I welcome you again for this video lecture to learn the procedure to connect load test on a three-phase cool cage energy efficient induction motor. So this is one of the very simple experiment we are going to do in our AC machines laboratory. The objective is to conduct load test and thereby to obtain these performance characteristics as of the given three-phase energy efficient induction motor. So this is the circuit diagram, and you can see that there are various components available in this one, and this represents a squirrel cage induction motor. So the outer surface represents the stator, and here this represents the inner more part. It represents the squirrel cage model of a squirrel cage rotor. So each and every round symbols represents the copper bar embedded over the surface of the rotating rotor. So again in this circuit we have a motor is coupled with a brake drum, and we have a digital multimeter, and there is a DOL starter. Okay, how do you do this experiment? So give the connections as per the circuit diagram, and now you have to close this DPSTS. This DPSTS, the supply is given to the DOL starter. Using the given DOL starter, start the motor. The machine will naturally start rotating at a speed, so that is the rate of speed, which is always slightly lesser than the synchronous speed of the machine. So what you have to take now is a reading under the no load condition, a set of reading under the no load condition. What are those readings? You have to take the line voltage, the line current, speed, and the wattmeter reading, that is the input power. And of course W1 and W2 are going to be 0 now. So then gradually you have to tighten this W1 or W2, either W1 or W2, and that is you are going to add the load, a mechanical load, gradually to the induction motor. For each and every addition of the mechanical load, measure the line voltage, line current, input power, speed, and the mechanical load that is applied to this. So you have to repeat this process until the rated line current is achieved. So that is the machine is loaded to its full load. So once the full load is supplied and you got the rated line current to the ammeter, I recommend you to take one reading up to 20% overload above the rated current. For example, if it is 10 amps is the rated current, means you can go up to 12 amps. So you can go so that to get a perfect performance characteristics curve. So once all those readings are taken, repeat and check until the rated current is achieved, and one more reading above the rated current. After getting this, do the calculation. After doing the calculation, draw the graphs. So draw the performance characteristics of the given motor, that is output versus the efficiency, torque, speed, line current, slip, and the power factor. Also draw the torque versus slip characteristics. So compare this with the other squirrel cage induction motor, in which you have already done or you are going to do in the other laboratory, which is not supposed to be an energy efficient motor. Compare the efficiency and other performance of this machine and justify your findings in this experiment. You must write it as a report and submit it along with your observation as well as in your laboratory report. Okay, thank you.